to call the meeting to order. Please rise and join me in the Pledge of Allegiance.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you. Madam Clerk, would you please call the roll?
Certainly. Supervisor Moore.
Here.
Councilwoman McNamara.
Here.
Councilman Iacilli.
Here.
Councilman Pell.
Present.
Councilman Martell.
Here.
All right. Today, welcome everyone. This is an exciting work session. We're going to get an update on the Riverside wastewater recovery facility. Why doesn't everybody just introduce themselves for the audience?
Let's go left to right.
Okay.
Zachariah Floor, I'm at Site Specific Design, representing E1.
Sean Cameron, Site Specific Design. We are the E1 representatives for this territory.
I'm AJ Brooks with Arcadis. I'm the project manager for the design of this project.
Vanessa McPherson, also with Arcadis, assisting AJ Brooks with the design team coordination for the project.
Janice Scherer, Town Planning and Development Administrator.
I'm Steve Hayduck from Hayduck Engineering. We're the town's sanitary engineer.
Teresa Mason, Principal Planner.
Thanks, everyone.
You guys are responsible for this?
The Time Machine Pod.
That's good or bad?
We had a whole discussion about it before you got in
Yeah.
there. So just as a quick intro before they jump in, we talked last time with Paul Knight and Elizabeth Dillon from Historical Concepts, and they're on their way to doing the pattern book and all that good stuff. And then this is, we're about at 30% design now for the sewer, and there's been some design decisions and things that Arcadis is going to discuss and then next steps forward. So thank you both for being here, and all of you, and take it away.
Thank you. It's our pleasure to be here. We're really excited about this project and thrilled to be involved with it. So as Janice mentioned, we just submitted our 30% basis of design report for the water resource recovery facility and collection system that's going to be serving Riverside. So today we have a short agenda, but a lot to cover. And I just want to open it up to, if there's anything that we're covering and you have a question about it, please just jump in and ask. We want this to be more conversational and less PowerPoint focused. So please don't hesitate to jump in. But we'll start out by just talking about the overall site layout for the facility itself, and how the treated effluent from the facility will be discharged. I'll turn it over to AJ, and he'll talk about the treatment process and equipment selection that we've done thus far. And then we'll turn it over to E1 site-specific sales to talk about the low-pressure sewer that we are proposing to use for the collection system. We'll give some highlights on public engagement that's been done to date, overview of cost and schedule, and then again, questions throughout and open discussion at the end. So just for some context, the design capacity that we're looking at for the facility at its build out is roughly 500,000 gallons per day, or 500,000 gallons per day. And we're breaking that into two phases. So phase one is the parts of the district that are approved in the current map plan and report. And we identified the flow associated with those current users based on their water use data at just under 100,000, more specifically 95,000 gallons per day. And we added on top of that for phase one an allocation for that future development that is being worked through with Historical Concepts that Janice mentioned. So we have about double the current usage as an allocation for future development, bringing the phase one capacity to 200,000 gallons per day. And then in phase two, similarly, the identification of current usage based on water use, a build out or a addition for future allocation for development, and then a total. So this is just to give you some context on what we're looking at for the capacity of the facility. And then in terms of site layout, so what we're looking at here on the right-hand side is the loop of Enterprise Zone Drive that swings around. Our facility is the light gray rectangular box that has a darker gray access road around it. So that's the WRRF facility. What's highlighted in color here are the leaching galleys. So all of the treated effluent from the new facility will be discharged back into the ground through leaching galleys. So the blue area at the north side is a reserved area in accordance with standards. We have to have 100% reserved area if it's ever needed in the future.
Is that a county requirement?
It is, yep. And then the yellow is the leaching area that's associated with the phase 1 flow, that 200,000 gallons per day that we just went through. The green is phase 2, so that 300,000 when we get to that point. And again, all of this is below grade. The next slide goes into a little bit more detail on that effluent discharge. So it shows a schematic of what a leaching galley looks like. There is another county requirement for the minimum distance of the bottom of the galley to the highest recorded groundwater. We did some modeling because the flow that we're discharging back into the ground does elevate the groundwater table slightly in that area. So we will be bringing in some fill to raise grade to maintain that required clearance between the bottom, excuse me, of the galley and the highest groundwater. But that's just some elevations to give some context about that discharge.
Will it require any kind of fencing then if you're raising the grade?
We'll have to look at that. We may need some retaining walls or something just to make sure that we don't have anything steep in terms of drop off, but that'll all be advanced through detailed design.
And there's gonna be a site fence around the entire property, for security reasons.
That's a good point. So another thing that I should have highlighted, excuse me, on that first slide, we have areas identified on the site for stormwater management. And our goal here is really to make them another educational component of this project. Our site's very close to the Phillips Avenue Elementary School, so we're very cognizant of that. We'll talk more about that in the outreach that we've done. But we really want to use this facility as a tool to inspire future generations about the importance of water quality, especially in this area. So the stormwater management is another mechanism that we feel we can do that through. So a lot of people think of bioretention as just a big divot that's grass and kind of an eyesore. We're planning on being very intentional with landscape design and specific native plants and really making it something that's beautiful and not something that's just a big hole on the site for stormwater management.
That's good.
And another important thing for our team is thinking about what the facade of this building will look like and the aesthetic of it to fit in with the existing architecture of Enterprise Zone Drive. So what's up on the screen that you can see are visuals from some of the existing buildings in the area. And then we took those as inspiration. On the next slide, there's a conceptual rendering of what our WRRF, our treatment facility, could look like to fit in with the neighborhood and really add character. So the top is the rendering in 3D, and then the bottom is a sectional view through the facility so that you can see that the tankage where the actual treatment is happening is depressed, so that's below grade. And then everything above grade is really the support systems that support that treatment in the tankage that's below grade.
We would really want it cladded like that previous picture, though.
Yes.
Okay.
And AJ wanted
It's
me
a little
to
plain,
mention.
but yeah,
it's
we
a
want the
plain.
little, yeah, we want the
Little
first one.
architectural details.
And when he showed it to me, I said, the color. So all of this is flexible.
Yeah.
And we didn't want, like,
Yeah,
I know it's
I don't
hard
know if you want it
see
to be
something.
brown.
No. There'll be plenty of brown, but it doesn't need to be outside the building.
But everything that is open on the tanks are gonna all be contained inside the
That's
building.
right. Everything will be, anything that's outside is covered. We have some sludge storage and holding tanks that are outside of the footprint of the
You
building.
can see that on the bottom left of that cutaway. That's below grade with the cover on top, so nothing that's going to be exposed or seen from the road
Okay, thank you.
or smells.
And everything is odor controlled as well, which we'll get into.
And that's gonna all be on grade that we have now? You don't have to raise it at all, it's gonna be as is?
We're gonna need to figure out the entire site grading, because as I mentioned, we do need to bring in some fill for the leaching galleys.
Right,
So
but the building itself?
the
most
building
likely
itself,
will
it's
stay
not
on
going to
grade.
be elevated. No, it'll be on grade.
So next is the process itself, and this shows a process flow diagram. On the left, you'll see that represents the individual homes, the E1 pump stations, and the low-pressure sewer that brings it to the wharf. You'll have 2 influence screens that's going to screen any rags or other items that need to be removed from the wastewater before it's treated, followed by grit removal to get any sediment or oil material that needs to be removed. From there, it flows into biological tanks. That's where the nitrogen removal is going to occur. You're going to have a pre-anoxic, which is in the absence of oxygen, then an aerobic tank, and then a post-anoxic. And that is all intent to remove the nitrogen from the effluent. From there, it goes into a membrane bioreactor, and what happens there is water flows from the outside in almost like a straw through the sides of the membrane, and up it's pulled up through, and the effluent out of that is extremely clean water. From there, we're making provisions to allow for chlorination in the case of there's a plant upset or something. It doesn't, we may not need to do it all the time, but we want to make provisions for this, and that can help with odor control and biofouling that may occur that in leaching. So we want to make these provisions. You may not need it, but better have them up front than having an issue later on. And then it will be sent to the leaching galleys.
Is there any polishing filters, like there's a last stage, or you don't feel it's necessary with this kind of technology?
With the membrane bioreactors, you do not need that polishing filter. If we went with the SBR that was originally proposed in the previous engineering report by Nelson and Pope, then a polishing filter would have been required. Solid, so that's the liquid side of things. So solids would come off of the MBR system, and in phase 1, they're going to be sent to an aerated sludge holding tank and be trucked directly to Bergen Point. In phase 2, thickeners are going to be added to the project because at that point, the cost benefit analysis shows that once you get around 200,000 gallons per day to 300,000 gallons per day, the cost to thicken is cheaper to truck thickened sludge than unthickened sludge. So
Reduces the volume, basically.
Yeah, so less trucks traveling to Bergen Point, and it was overall cheaper to do that.
I was glad that the county was willing to work with us on that and accept the sludge at their facility.
Yes. So with the thickening sludge, there will be a thickened sludge storage tank. That's where that will be pumped out in phase 2 to the trucks hauling it to Bergen Point. This next,
How much sludge do you think you're gonna have, Adam? It's hard to tell.
I don't have that information off the top of my head. I can definitely get that information for you. I think for phase 1, we're talking like 3 to 4 trucks a week max. At full build out, we're talking less than 10 trucks to Bergen Point.
Per week.
Yes.
These are tank trucks?
Yeah, it's similar to a septic hauler hauling truck. And really, that's the only location that there's a potential that there may be some odor because you're pulling that sludge out, but the sludge itself is going to be contained, and it's really just a cam lock fitting that's connecting to the sludge holding tank to pull out. So this represents the interior of the treatment plant building. There's going to be some provision on the lower right for the locker rooms, a lab area, a break room, and an office area. The rest, the process areas are going to be contained in a different section of the building to allow for better odor control and for HVAC purposes. Inflow flow will come in on the upper right in the headworks, and then it'll flow to the tanks, going right to left on the screen. The tanks on the left-hand side are the membrane reactors. The rooms on the southern part of the building are the ancillary equipment, so chemical room, the thickening room. Again, the thickening equipment will not be installed in phase one, but we're making provisions for that and having it size and everything now, so it's easy to be installed when phase two arrives. The blowers and compressor room and the electrical room.
I would just have you remind the board about the fact that the tanks are also going to be sized to.
Yes, that's going to be the next thing that we, so the building is roughly interior 180 by 120 feet wide and long. So this next slide goes into more of the phasing. So phase one, all of the concrete tanks are going to be installed. The entire building installed as well for phase one for the full build out. The lower tanks that are in that bluish gray color, that's the tanks that are going to have equipment installed as part of phase one. So the mixing equipment, the aeration equipment, membrane equipment, all will be installed in those two trains as part of phase one. The tanks that are in the yellowish color, that will be installed in phase two. The tanks are going to be there, but there will be no equipment inside the tanks. And we are providing flow equalization inside those longer tanks on the right-hand side. So as flows equalization needed, it's going to be just raising and falling inside the tank. We call it freeboarding. So there's just enough capacity in that tank to allow for any variation in flow from diurnal. In the morning when people are getting up, flow tends to rise and then it dips off and then rises again before around evening time. So that is all going to be handled in those biological tanks. So this is a summary of the major equipment that's going to be comprised in this WRF. So a process area, there's going to be two blowers, that's duty and one standby for phase one, and then in phase two, an additional blower will be added. As I mentioned, the diffuser grids for aeration, one for each of the tanks. Two of them are going to be installed as phase one in phase two. Anoxic mixing and sludge mixing. We're using a coarse air, big bubble air mixing. This membrane scouring pumps, permeate pumps, return activated sludge pumps, waste activated sludge pumps, air compressors to control valves as needed, piping instrumentation, and chemicals. We're anticipating sodium hypochlorite, which is for cleaning and disinfection, citric acid for cleaning. Alkalinity may be needed to be added for treatment and removing of nitrogen and carbon as well. So just this picture kind of gives you an idea of some of the equipment. So the upper image, that is going to be what's installed in the headworks. It's two screens of a grit. It's all packaged on a skid that will be, it's almost plug and play. You bring it into the room and attach pipes to it and odor control, and it's ready to go.
I actually have a question about the building. Are you putting solar on the building to offset some of the electrical costs?
We are looking at that. The building is not quite oriented in the correct direction, but we're going to look at the cost benefit of doing that. For mixing, the lower right depicts what the compressed air mixing environment system looks like. It's the air compressors, air holding tank that is controlled by solenoid valves, and it pushes air in and it creates this bubble that mixes the tanks. The middle picture is the rotating drum thickener for solid thickening. And then the bottom left are the odor control vessels that we're going to be, that's really the only component that's going to be outside the building, behind the building for removing fungin.
You're talking about the carbon vessels will be outside the building?
Yep. Okay, moving on to the collection system. I know you have a printout of the current map plan report figure showing the Riverside Sewer District. We have a figure of that on the screen as well. On the screen, our figure is a little bit different than what you have in front of you, but the green represents the parcels that make up phase one that have existing buildings on it right now. The blue line is the sewer district boundary, as it is right now. It's interesting, we should note that the Phillips Avenue School, while not in the sewer district as part of phase one right now, we have made provisions to include them as part of phase one flow. So we'll have to work on, they may be an outside user for phase one.
Out of district
They're gonna
connection?
contract in, which we have all those municipal agreements in place.
The black line represents the future sewer district when full build-out is completed, and the purple parcels are those existing parcels that would be making up that sewer district in the future. The
Wait,
the
what?
non-colored right now are vacant parcels that could be developed in the future.
What are you saying, that the black or the dark gray is proposed?
So right in the middle, that's the proposed wharf, the treatment plant property. The black line on the very outside of the parcels that are shown, that is the future sewer district boundary.
Most of those properties are all preserved anyway, so it doesn't really have any bearing on anything, all the top.
You mean
Yeah.
the green?
No, he's talking about this black line,
I
all
think.
the way at the top, the whole thing.
Oh,
So it encompasses areas that are preserved. It's the full hamlet of Riverside is the district is, boundary is going around.
I see.
So as how we've gotten here, back in April, May, we had submitted a preliminary engineering report that looked at alternatives for the wharf itself, the technology used for treating, as well as the sewer. And we looked at traditional gravity sewers with larger pump stations. We looked at low-pressure sewers, and we looked at vacuum sewers. Based on a cost-benefit analysis, we had recommended the low-pressure sewer with individual grinder pumps at each property. That provided the lowest overall life cycle cost and provided a ease of construction that traditional gravity sewers cannot provide. We have high groundwater in this area. So some of these sewers, traditional gravity sewers, would have to be constructed 10+ feet deep in groundwater. And over time, that would result in the groundwater getting into the sewer. So you're going to be treating groundwater and reducing the amount of flow that could be treated from parcels instead of where the low pressure sewer that's actually constructed closer to the ground surface, typically 5 feet and above. We're proposing about 4 feet deep. And it's just much easier to construct than gravity sewers. And its operability, it's very easy as well. Another benefit is there's no large pump station. I think that previously there was 4 pump stations being proposed. Some of them were on archaeologically sensitive areas, so that is no longer required.
No pump station.
Just small grinder pumps, similar to what we see over here.
And this was peer reviewed by our reviewing Hayduck, and you agree this is the best approach?
Yeah. So low pressure sewer systems, great for flat terrain, high groundwater table, undulating terrain. It just makes things much easier. And we have site specifics who are a rep for E1 in this area here, and they're going to give a little bit of overview on E1 and their experience here in Suffolk County.
Okay.
So yeah, any questions at any point, feel free to jump in. I'm gonna try to stay 30,000 foot view of this, but we can get pretty deep into the weeds if anyone wants to go that direction. So just a little quick history on the technology itself, just so everyone understands. This is fairly new to the Long Island market, but it's not new in general. They've been making these pumps and putting them in the ground since about 1970. Was 4 guys from GE that branched off to develop the E1 product. It's a U.S. manufactured product, actually manufactured here in upstate New York. It's long history. We have just shy of 1 million pumps in the ground. In fact, next year we're throwing a 1 million pump party, so that'll be fun. But as you can see in the sheet and on the screen here, just things we've done in Long Island and New York City, which is the territory that me and Zechariah are directly responsible for. When we took over this territory as a company for E1, we took over in 2016. There had been companies working in this area previously and just not a lot of growth and stuff, but there were these needs, as you guys are looking at now, where sewering some of these areas with higher groundwater tables and stuff like that, it's very challenging, and putting a large diameter pipe into deep groundwater applications can get very pricey. So this technology kind of gives you the ability to sewer those homes without some of those environmental impacts and cost of deep excavation, shutting down major roadways, and things of that sort. So recently we did about 3,400 units in the Carls River area. We're currently probably 75% done, putting about 2,500 more pumps into the Forge River, Shirley, Massachusetts.
Sorry.
Good try.
So, and these are all Suffolk County projects where we're working with DPW. A lot of this flow does go down to Bergen Point, but similar to what you guys are talking about here with the Forge River, Shirley, Massac area, that had a treatment plant built very similar to what you're talking about here that was designed flow for that area. And as a result, you're able to get much more efficiencies, not only from your collection system, but from that treatment plant, because you're not worrying about this I&I where you're getting groundwater in and you're now paying to treat that groundwater.
These are county projects, you're saying? Because I thought the county preferred the gravity.
They probably did up until about 5 years ago when these projects started. And it was the same idea as they had done some feasibility studies back in 2012 to look at sewering some of these 0 to 2 year groundwater impact areas and looking at the cost value analysis of gravity versus vacuum and pressure and other things. This was the way they decided that they were able to sewer more with the same amount of money or save money, depending on which way you looked at it. So. But yeah, so these are Suffolk County DPW projects that we've been doing directly. So those are, after we install them or the contractor installs them, they're actually owned and maintained by the county themselves. So again, we've done a lot of homes here on the island so far, more than 4,500 to date, and most of those have gone in probably within the last 2 to 3 years. But we have some in Patchogue that have been there over 20 years. They were kind of, on the island, the first people to really adopt this technology at a larger scale than just a one-off building or something like that.
So the ones that you did in Patchogue, is that the housing units or is that part of Main Street?
Both. So there were some housing units that went down on West Ave back in 99, 2000 area, and then we've done stuff on Main Street down there from then on forward. And we have connected, I was just at one yesterday. We add things to Main Street and Patchogue weekly at this point. Fun
Cindy,
fact
did
for
you
anyone who
have a
doesn't know, your building here has 3 of our units that are operating this building right now. So those
Oh,
went
wow.
in as part of your project here. So.
Oh, they're a recent project.
My question was, did these get maintained by the sewer district, or are they up to the homeowner to maintain?
So the ones that went in the late 90s in Patchogue, and that was many years ago, those were originally put in and they were the responsibility of the homeowner. With some of the funding that had come through for these most recent projects, it was FEMA funded. So essentially you can't take government property and gift it to a homeowner. So the county had to, as part of that, they paid for the installation of the unit, the abandonment of the existing systems, and they own those units for O&M essentially for life.
That's what we're planning on doing as well, and having easements to them.
So these are gonna go on the property owner's property.
Correct. But they will be essentially owned by the village in this
The
case.
district.
The district, yeah.
The town is the sewer district.
And we'll touch on kind of how that works a little bit and how we, partner with you guys and however you want to handle that, because there's essentially 3 different ownership models that most people land within. But yeah, so, a lot of future projects on the books, where we're have plans just like this where it seems to be, obviously I'm a little bit biased on this, but, in general, it just, as far as sewering high groundwater areas, Long Island, this is probably the best technology to get to that point, when you look at those cost-benefit analysis.
In the 25 years in Patchogue, have you had to upgrade the pumps and the systems?
Yeah, so the pumps have about a lifespan of maybe 15 to 20 years. So the traditional ownership model of this product is we put it in the ground today. Part of the systems we're doing for the county, and same thing I would recommend for you guys, is what we call our certified installation program, which means whoever is going to be the contractor that's putting these in the ground, we actually go in and we train them on how to properly install these. They're probably one of the easiest systems when it comes to a pump station, lift station to put in, but we want to make sure through 50 years of experience, these are the things we've seen. So the most common things that we've seen cause systems to have issues, number 1 are installation issues. Number 2 are homeowner interface, which is something we can never control. And then number 3 are, acts of God, lightning strikes, power surges, hurricanes, whatever it may be. Aside from that, these systems are like the E1 systems are the only ones I can speak directly about. They don't require any regular maintenance. There is no, go visit them. They go about 10 to 15 years before the alarm will go off. That alarm will sound. There's a 100 decibel audible and visual light on the panel that would go off. But with the systems we're doing for the county, and same thing I would recommend for you, is there's also a communication system with a modem built into the system. So it will send a text, email, or phone call to anyone. So if you went into Bergen Point or into the new treatment plant that they built in Shirley area, they actually have a screen on the wall similar to this, and you can actually map every one of our units that's in their system. And everyone gets a little circle, and a green circle is good, red is not, and yellow is like, you might want to take a look at that one. And there's other different ways to navigate that screen, but if a system goes into alarm or loses power, my phone, his phone, and anyone at Bergen Point all go off simultaneously. And then we decide the best way to handle taking care of that.
What were you saying, though, 10 to 15 years?
So that's the average mean time between service. So typically what will happen is this unit will go on the ground, we go out, we do our startup on it, which is part of that certified installation program, as well as that we have to go out and certify the installation. And then the homeowner, it's kind of a flush and forget. It's very similar to gravity. They never know this system operates until at some point down the road, the alarm's going to go off. They're going to forget even where it was until they figure it out. And either it's going to directly call to whoever's maintaining your system, or the homeowner might pick up the phone and call the phone number on the box. And what'll happen is whether we go out or someone from your organization goes out, and we, repair the pump at that time. Now, that repair could be variable. It depends on what caused the pump to fail. There's switches in the pump that turn the pump on and off. Maybe one of those wore out over time. It's a mechanical device. It will fail over time. All the way up to maybe the pump is a complete loss and the pump itself has to be swapped out.
But generally, you said generally they last between 15 and 20 years?
Right, so typically we get a call in that 10 to 15 year range. We go out, we repair the pump, and then they'll get normally about another 5 to 10 years. Now, there's anomalies both ways. We've had pumps that we've gone to that are 25 years old and never been touched. Mm-hmm. We have ones we go to that have been in 25 days, and the homeowner put enough grease down the tank in that amount of time to clog up the system. And it's not a pump failure, it's that we now have no water space inside the tank, because I don't know if they just do a big bucket of fried chicken every day and dump it down the drain, but a lot of grease in a short amount of time, The good news for you is when you talk about lift stations, for example, is when you have lift stations and maybe you have some of these maybe not very nice sewer users, we'll call them, that might be doing things going down the drain that aren't great. That's going to be caught at their house. So you're actually going to know who those people are. Versus when you have a big lift station, you just have a conglomerate of, don't know where this is coming from, but we keep having these issues.
I heard that's a problem with the grease, and so we should do some education when these go in, make sure that we advise the homeowners that that is not okay.
We have a lot of over 50 years of documentation that, like we have mailers and stuff that we can give you, and a lot of times districts like yourself, even with the quarterly mailing of a sewer bill, will just make that part of the envelope stuffer.
Maybe you can give us the mailers now, because we're actually thinking about having at the transfer stations, a grease collecting, where people can bring their grease and oil in
Yeah,
to, instead of going down a drain.
I can email those to you. We have a lot of documents on them.
And do you think it's time to show that?
Sure. So, we're on this page here and, of kind of what do they look like. So we'll start with this. So we did a lot of town hall meetings for the county projects and
We might have to move that so they can zoom in on it.
okay.
Just.
Kevin, can you get that?
Actually, I don't know. Kevin, what?
I have it in frame.
Maybe put a small window for that.
Kevin, let us know when you have the camera on the thing.
I have it on it already.
You can
So-
go from that camera right there.
One of the first questions we get, and that's why we put these pictures in there, when we do these town hall meetings, what we'll also do is we'll bring a couple demonstrations of what the homeowner actually sees, because this is not what anyone's ever gonna see. This is in the ground profile view. I've had people ask me like, what do you do about the hole in the tank? There's not a hole in the tank when this goes to the ground. It's just for demonstration purposes, but this tank is also a little bit shorter than the standard you would see. So our standard tanks that go in here are 93 inches tall, so about 20 inches taller than this. And the reason for that is, on the other side, or actually here, you can see this is the discharge of the station. So it's an 1.25 inch discharge, small diameter, because we're grinding everything up. And we want to make sure that that stays below the frost line. So here in Long Island and there north, about 4 feet below grade is where we want to keep that pipe. Up in Canada, it's a little bit deeper. So the only thing that sticks out of the ground is from here, and there's actually cast right into the tank for the contractor purposes. This is ground burial depth and up. So about 4 inches of this tank sticks out of the ground. And this is the only other thing that the homeowner sees. E1 works regularly trying to make these a little bit smaller, a little bit tighter. But for all of the things we talked about, generator receptacle for power loss and communication systems that are in here, this is about the size you're gonna see for the foreseeable future. But pretty inconspicuous, comfortable color. So this unit gets installed in the house at each property. What happens is you have an inlet on one side where the water flow comes in from each house. That water flow fills up in the bottom of the basin. The operating level in this tank is normally from about here to here. It's not very much. Part of that is someone brought up odors, right? If you keep large amounts of sewage on hand, that sewage goes septic. Septic smells really bad. So we want to keep low volumes of sewage on hand. We want this to turn over about 10 times a day, which is part of the entire design of this system. So we keep low amounts of sewage on hand. As that water level rises, there's actually pressure switches that are located way up here in the head of the pump that turn the pump on and off. There are many different level sensing devices to do this. We prefer the pressure switches because they do not come in contact with the sewage. So therefore, when there are things like grease and wipes and stuff like that that get into the water, it doesn't foul up the level sensing devices, so we don't have failures and someone has to go out for that. When the pump turns on, this is a 1 horsepower, 1750 RPM progressive cavity semi-positive displacement pump. It's a lot of information, but it's a 1 horsepower pump. It's very small in the pump world, but it's probably the most powerful 1 horsepower pump you'll ever see. And that's because it's that progressive cavity technology. So the best way I describe this to people is if you had a very fast race car and a pickup truck. One's fast and one can move a lot of weight. This is going to move a lot of weight, but not very fast. We don't need fast. We're talking about residential flow. This pump, one pump, horizontally, if we did not change elevation, can go about 3.5 miles with one pump. You start combining them together in a collection system like you're talking about, just like in a horsepower, additional horsepower in a car, we can move more fluid further with more pumps connected. So every house will have this unit with that 1.25 inch line going out, and that will connect into what we call the force main in the road. And that force main in the road will continue to get larger depending on how many of these units are connected to it. So for a project like this, depending on how many connections, your largest pipe might be 8 to 10 inches maybe. We have some of the ones that we did in Carl's River. I think there's like that 3,200 pumps in Carl's River actually connects to one pipe at the end. I believe that's 12-inch pipe. Because we're grinding everything so small, we can keep that smaller diameter pipe, which is less expensive to install in the ground. And it can also be horizontally drilled, which means less open cutting of your roadways and things of that sort.
What is the pipe made out of?
So we recommend HDPE pipe, which is the same thing this tank is made out of.
Okay.
As we talked about, when you talk about inflow and infiltration, very old sewers, you had like, clay pipe, and then you had cement pipe. That breaks down over time. Gravity pipe, that's typically used nowadays, you're talking, PVC and stuff like that. At the joints over time, they can separate. HDPE pipe is a very flexible pipe, so you can actually go, with the terrain of the land, or if you're drilling and there's a tree, you go around the tree. If you come across to a water line, you can actually dip right underneath it. It's very flexible pipe. They have not yet found the lifespan of HDPE, and it's been over 50 years, so it's still going strong. So that's why we default to
And it's
that.
pretty easy to add on to.
It is. You can fuse it, you can couple it. There's many different fittings and things available for that. So.
When they come on big rolls, it lends itself to that horizontal directional drilling installation technology.
Yeah, just feed it
Basically,
right in.
pull the pipe through the drilling.
My question on the unit where you mentioned the generator plug, does that mean like if your power's out, you can't flush your toilet?
So what happens when the power goes out is, there's gonna be some amount of water already in that unit. We don't really know where that water level's at. So when power goes out, the first thing that happens is your dishwasher doesn't work, your washing machine doesn't work. So water usage drastically drops dramatically. But you can definitely flush your toilet, you can wash your hands. If you had a gas hot water heater and you wanted to take a shower, you could, but it goes back to the educational thing. What we try to do is educate people that there is a limit, and we don't know what that limit is because we don't know exactly where that water level was when it started. So there is 70 gallons of storage capacity in this tank below the inlet. You still have some additional storage in the inlet pipe itself, and depending on your elevation of your house versus the lid of this, you could fill up the whole top of this tank and overflow into the front yard before it would ever back up to the house, but that's not something we would promote. What we try to tell people is when the power goes out and or when the alarm goes off, try to be as frugal with the water use as you can until someone gets out there. Now, in a power loss situation, there's not much anyone in this room can do. We don't control the power company or power lines or, natural disasters. But if you had a generator, you could hook that up to it. That generator that would run this pump is one that's sold at Home Depot every day, depending on the level of quality you want to own, $300 to $1,000.
And then if you ran that and you got it to discharge, then you have your whole storage capacity back.
Well, you could just leave it hooked up to the power and you're just same as having power at the house. These pumps, again, they're 1 horsepower. So they draw about 6 amps on 230 volts, which is I just bought a refrigerator. It draws about the same as that. It's a very low power consumption. And again, it runs about 10 times a day. So what I typically recommend to someone is if they're going to buy a generator, hook it up in the morning. If the pump needs to run, it'll run. When it shuts off, disconnect it. Now you can use that to run the rest of your house. Maybe you do that 3 times a day. Just hook it to that tank to let it pump down. But I personally, I have myself, my wife, and 2 teenage daughters. We average about 130 gallons a day normally. So if you took washing machines and dishwashers and showers, because I have an electric hot water heater out of that, flushing toilets, washing hands, and it's not a lot of water. New low flow fixtures, most toilets are 1 to 1.6 gallons per flush. It's a lot of capacity, but you want to be aware of it.
Yeah.
So again, what we try to do is educate homeowners on there are limitations in power outages.
So what you're saying though is if there's no power to the unit and it does overflow, you won't get the alarm?
You will not get an alarm. So what happens is the power goes out, and with the communication system, someone would be notified. So maybe it's just one road that goes out without power. Those homeowners could choose to hook up to the generator receptacle, or in the case of like Carl's River with the county, they actually have generators mounted on pallets that they run on trailers, and they'll run out and hook up to a house and just work their way down the road one at a time.
Cindy, just for context, I live in Flanders and we're basically all on the same grid for Riverside. We were without power for Hurricane Sandy for 26 hours because if you look at the region, there's a lot of critical services that need to be powered right away. The county center, the jail, the Riverhead Sewer District, the Oak Avenue, Wellhead, and the Flanders Fire Department, the Riverside, Flanders ambulance. So those services get put on really quickly, 26 hours during Hurricane Sandy.
Wow.
That's all we were out of power. So this should hopefully not require any major.
And I know I'm going like down the line here, but it's just a question
You had a
that
good
I
story
wanted.
about what happened in Key West that you should.
Yeah, so 2 things to that. So one is if you take Hurricane Sandy out of play, the average power outage is about 15 minutes on Long Island. But even, we've had a couple over in Carl's River just in the last couple of years. I think the longest one I saw was an hour. So I think you have more than an hour's worth of storage in there. But yeah, so we sewer Key West with E1 technology. So if you get into the Keys, every single thing you see has one of these on it. When Hurricane Harvey came through, knocked out power in Florida for like 7 days. When the power came back on to those units in Key West, the pumps just turned on and pumped out and went back to the operational. All of the gravity pipes that had filled with all the dirt and gravel and stuff from being overrun with the groundwater, that took them 2 weeks to get them back online. So because it's a sealed system, which is part of that I&I, we aren't taking on groundwater and all those things that, technically in a natural disaster, it's a quicker to restore system in most cases. If the panels go underwater, it gets a little tricky. But I can tell you, as I tell a lot of people I work with, I could pretty much make a pump run. As long as you give me a power source, I can make a pump run. So there's ways to get around it.
So what happens if it would just continue to fill, the alarm wouldn't go off, but then it would continue to be contained in the...
Eventually, if someone just continued to use water and there was no power and they kind of ignored that, one of two things is going to happen. It's either going to overflow out of the lid of the tank, which is better for the homeowner, but not very good for the environment, or it's going to back up into their house, which they don't like as much, but normally then they do stop using water.
But what, when it gets to the electrical part, would that damage it if
No,
it's?
so the entire pump is submersible. And in fact, up top here, I can show you, we have a neat feature built into the E1 pump. It's called an EQD. So it's what we call an electrical quick disconnect, where we can actually disconnect the pump from the power source to pull the pump out and swap it out. This fitting itself is even NEMA 6P rated, which means it can go underwater like 30 feet for 48 hours, and it's rated to not take on any water. So technically, you could take this unit, take the lid off of it, drop it into the ocean, and the pump would still operate. We can't dewater the bay, but it wouldn't affect the pump to try. Pumps want to run. They would just sit there and run. It just would not be able to really keep up with the flow. But the pump is fully submersible. There's no part of it.
And then the vent pipe is internal?
Yeah, so the vent pipe is built in where it actually vents out under the green lid you see at the top. And years ago, E1's first iteration of this pump was the 200 series, and that existed from probably the 85 to 94. They actually had a vent on the side of the tank. Most people, they see a vent, they smell something. They don't see a vent, they don't smell anything. It's more in your mind than anything else. So raw sewage, you may realize you pass every day, you wouldn't even notice it. It's not that bad of an odor. Septic and grease, whole different world. Zechariah also gets to work with his father on some wastewater treatment plant operations where, he gets to really get deep into that stuff. But the venting out under the lid, because we're keeping such a low amount of sewage on hand, I have pictures and some slides that I have for different presentations where we've had people set up picnic tables over the top of these lids, and that's where they eat their lunch. And no one knows what that green lid is, but it's typically not an odor issue, but we do need a nice fresh air vent. So depending on the groundwater elevations, so if you had an area that you say, hey, like in Patchogue, some of those areas down on the South Shore, there's houses down there that their front yards go underwater 4 times a year. So in those cases, we have what's called a lateral vent system, where it's actually a pipe that comes out sideways, comes up the side of the house to a little snorkel vent, maybe 4 feet up or whatever is the high point that we want to make sure, because the pump does have to breathe. As water comes in and out, we have to be able to displace that air. So our traditional vent is what you see here, right up through under the lid.
You're going to be digging in the water sometimes to install those?
So that's what they did down, all the projects we've done so far, especially down in Patchogue. There's areas in Patchogue where they dig down 18 inches and they're already in the water. So this unit particularly, if you look at the bottom of this tank, this is the newest design. So E1 makes one pump, and they have 150 employees that build these pumps every day. They build about 225 of these in their factory in upstate New York every day. They have a team of about 10 engineers that sit around every day just trying to figure out how to make this better, stronger, more service-friendly, all of the above. So this particular bottom end of this tank was released to us in, we'll call it January of last year, 2024. And the idea was that prior to that bottom of that basin being that way, is we would say every tank that goes in the ground must have a ballast poured around it for buoyancy concerns. And that's a cost, and it's hard when you're handling concrete and stuff like that, and there's a couple different factors, but E1 Engineering spent about 15 years designing this tank before they would release it. The idea behind this tank was that you could take this tank and put it in the ground without a ballast, even in high groundwater areas, and it won't pop out of the ground. So I don't know if anyone here knows Tim Nordberg from the village of Patchogue, used to work for H2M Engineers, but Tim called our bluff. He's like, I don't believe you. It doesn't work. I'm going to make our guys ballast it anyway. So E1 said, well, what can we do to prove it to you? He's like, show me a test. And I can share you the white paper on this. So E1 at their factory dug 2 holes in the ground, lined them with pool liners, and put 2 of these tanks in those holes. The first one, per our installation instructions, they backfilled up to the bottom of the inlet with 3/4 inch angular stone. Nothing else. The second one, they backfilled completely with beach sand, which is not something we would recommend as a good backfill material. It's just too loose. And then they flooded both of those holes with water. And then we got 72 inches of rain, or 72 hours of rain over the next 3 days. So they couldn't be any wetter. And what they did is they shot elevations off the top of the tank, and then they shot them, throughout that process, and the tanks did not move an inch, even with what we would call bad installation practices. And then the part that kind of blew my mind as someone who does this is they opened up the lid and took a picture inside to show that they didn't have any water or anything in there, and I didn't realize they didn't even have the pump in the tank, which adds about another 100 pounds of anti-buoyancy force. So I'm not telling you to ballast them or not, but yeah, I could show you pictures of these we have in South New Jersey in a place called Grassy Sound. The houses are on stilts over the water. The tanks sit in the water below the house, and that's their gravity or their wastewater system. So yes, you'll have to de-water to put them in, but the tank doesn't care when it's in water. It's completely watertight, aside from that vent on the lid, which is why we need to know if the lid has a potential to go underwater, and we have to do a couple different things there.
Thank you.
So where are they placed in a yard by a house?
So that really depends on you guys and or the homeowner, and the engineer gets involved. So traditionally, the homeowner would say, I want it in the most inconspicuous spot it can be, maybe in the backyard under the bushes. But as part of this, if you guys are going to have any sort of ownership of these systems, you're going to need easements, and you're not going to want easements into people's backyards through the fence with the dog. So in Patchogue and in most of the areas in Carl's River and Forge River, they had them in the front yard, and the goal was originally to have them as close to the road as possible. Now, I don't know what you guys are looking at for your incoming pipes on these, but in some of the areas they use 6-inch DR18 pipe, which is much more expensive than 1.25 DR11 pipe. So very quickly they said, well, we're going to keep those closer to the house, shorten that larger pipe, which is also a potential source of I&I, and increase the pipe of the 1.25 inch, which is easier to install and less cost expensive, and then there's really very little potential leak on those pipes.
Most people have those shrubs and stuff around the front, so it makes it easier to kind of hide because you've got like a little bit of landscaping, and then you have the little tank cover closer to the house versus closer to the road. So
we do also have that very interesting decorative rock option you saw in the picture there, which we bring that to the town hall meetings because it's fun, because in Patchogue, before we ever did the first project there was another pump technology, and they had these kind of bigger, uglier lids, in my opinion. So we wanted to show them what our lid looked like, but we were like, hey, we have this decorative rock. So people would come by, they say, what's with the rock? I'm like, well, if you don't like the lid, you can hide it with the rock. They're like, well, the rock's uglier than the lid. We get the lid for free, so I guess that's good. But that's not a normal stone you would see in Long Island. But up in Maine, people love them because they just kind of blend in. But down here, we've painted the lids and done all different.
So
things.
the last question I have is, what about pump noise outside?
So if I turned that pump on right now, you might not actually even be able to hear it. In fact, we will tell a homeowner, if you can hear your pump run, please call us. That's not good. When we go out and we do startups, we have to put our foot on the lid to feel it running. You cannot hear it running. The decibels of the pump measured outside the tank would be, that you'd almost have to put your ear down to the ground to hear it. If you can hear the pump running, it's normally either the pump is chewing on something it shouldn't be, or the bearings have now gone bad, which normally in normal operation is about 15 to 20 years takes that to happen.
Great.
Is Baby Wipes gonna just like seize up the whole something?
No, so E1 is one of the only companies that subjects themselves to a test called NSF 1996 every year. And this is a test where they actually have to go to a third-party entity, or the party will come to them, and they actually say, they have a shopping list of things you have to buy and throw in the tank while the pump's operating. And it's fun if you look down the list. I mean, everything from feminine products to, cigarettes and things that people put down the drain and probably shouldn't. One of the items is a Matchbox car, but it can't be the cheap dollar store. It has to be Matchbox brand because they make a higher quality die cast, metal. And the pump has to operate through that test without any failure operation at all during that entire thing. And there's some things they'll say they have to put in, let's say, 10 baby wipes a day through the duration. The car only goes in once during the week, and they pass that test every year. The problem with baby wipes is in excess. So, alas, has anyone ever watched a grinder demonstration of a grinder pump? In our industry, it's something we see all the time. And people will show, like, look, this pump will eat a pair of jeans. Well, keep in mind, when the pump eats that pair of jeans, you now own it at your treatment plant. I don't think you want to treat pairs of jeans. That's not the ultimate goal. So an E1 pump will eat a pair of jeans. It would just be the longest, lowest grinder demonstration ever. It'd take about a week. We chew things into pieces. So we have a 5 1/4 inch inlet, which is pretty much an upside down garbage disposal. It's a very large, less likely to clog inlet. Flushable wipes float, they don't sink. And in any pump system, you never want to suck the water completely out of the tank. And the inlet for most pumps is at the bottom. So if our water level's here and the bottom of the pump is here, as you flush flushable wipes, they're going to build up at the surface level. Same thing with grease, floats on top of the water. So over time, if you're flushing 10 of those a day, that mass will continue to build up. And by the time anyone's pump grabs it, it's normally about a queen size sheet worth of wipes. Like I said, the good or bad part of it is you're going to know who those people are. They're going to have the interruption in the service, and it gives you another point for that educational, even if you could put these down the drain, you shouldn't. Because whether you had gravity sewer, right now what you have with cesspools and septic tanks, or even something like this, there is no system that would say, we want that. It doesn't break down well. So yeah, they will cause issues for anyone's pumps. We are probably more resistant than anyone else, but when they build up in there, and every house I've ever gone to that has excessive grease or wipes, no one's ever put them down the drain ever. They don't know where they came from. And then you watch husbands and wives kind of bicker with each other about it, but no one's ever put any of them down the drain. They just magically show up there.
The kid fesses up to the car, though, I bet. I flushed it.
Yeah, well, we've pulled, any of us in the sewer industry, we tell you all the stories of stuff we've pulled out of sewer tanks and pumps that you just try to figure out how it even got in there. But I had one, a guy got fired from a commercial place, and I guess he wasn't happy, so he opened up the lid of the tank and dumped roofing tar down there. That did not do good for the pumps. I do not recommend that. Dental floss is probably one of the biggest things, which again, in normal operation, not a problem. I went to a house one time, pulled a pump out, it looked like an actual rat's nest of dental floss. And the guy's like, yeah, my wife flosses like 18 times a day and flushes it down the toilet. I'm like, that's kind of weird and fine, but just put it in the trash. There's no reason to flush the dental floss. Cat litter, people like to clean their cat box and flush it down the toilet. Clumping cat litter is not made to go through pipes. So most of the things that will cause issues are things that should not be in the system at all.
So we skipped a couple of slides that you have printed out because I think Sean did a fantastic
Yeah, I
job.
apologize.
No, it was great. It's stuff that we talked about, so we don't need to necessarily go through all the slides, but just back up a couple. And I don't know, Avery, if you want to cover this one.
So as a design team, we need to work with the town to get some resolution and move forward before we really bring this to the community at large. So the one thing we really didn't talk about was approach for maintenance. So there's really 3 models. A company like Site Specific could be the owner's agent and take care of all of the maintenance requirements. Their number is the number that gets on the box, and they get the alarms and they go out and take care. It's a little bit more expensive, that option, but it takes all of that out of your worry. There's a hybrid approach where you may have someone on staff that does some of the more the routine maintenance and interfaces with site-specific over the long term, replacing pumps and stuff like that. Or third, you could have full ownership of maintenance requirements. So at some point, the town is going to have to decide what model the sewer district is going to function on.
Not just for maintenance, but replacement costs going forward as well.
So just to touch on that real quick, so you guys are gonna have, I think this project it's less than 1,000 total pumps.
For now, but with development, it's going to be
Right.
larger.
So in the initial phases, we cover about 50 to 60,000 pumps in our territory. Typically, for about 1,000 pumps, one person is all you would need. And that's from any aspect of that ownership at all. Unless you didn't want to do it at all, then you would need no one. And we have some townships that do that call us directly. We do all the service for them. We have some, the county right now, where we have that blended model, and then others that they pull the pumps, they repair them in-house, we support them as needed, and then they go out and put them back in.
What do you put it, like a tripod up to lift the pump?
No, so that pump, well, they recently just lightened it for us, so even before they lightened it, was about 105 pounds. So we pull them by hand. We do have a tripod assembly that we can use, but those of us that do it regularly, sometimes just like, by the time I set that up, I can just pull it out by hand. It's a 3-step pull process. Pull it with one guy. You could use the tripod, makes it even easier. And then you could just plug another pump in and drop it in, and then you bring that one back to the shop. The goal is to be on and off the customer's property as quickly as possible, and they have that, they feel like they were taken care of in rapid fire format.
Another decision that has to be made is electrical usage. So these pumps are going to be tied into each individual home. So whether there's some municipalities that have agreements with utility companies that it's directly tied to the grid and not to the homeowner, and they somehow manage to show a differential and pay that differential. Some municipalities, which we do not recommend, actually drop a single service for each pump station, which is crazy, because just the administration of that, having 600 to 1,000 additional electrical bills for the pump stations.
I mean, a 1 horsepower pump running
Right.
6 to 10 times a day, how much electric are you talking about?
Could be $40 to $100 a year, depending on your KW rate, but it's minimal.
Okay.
E1 was, when we were having discussions, they estimated $25 a year. So you could subsidize the sewer rate if you wanted to. There's many different things that can be done.
We are trying to work out a subsidy program for, the sewer district fees for low-income residents. So this could be another sort of thing where they submit it and we work out the billing. So that's one of the kind of goals here, is to keep the costs minimal, so we can work on that together. We just want you to be aware that these are decision points that you as the board need to make.
And we're just talking about the existing homeowners, right?
Existing.
Not new.
Not new. New, can you explain what will happen for the new building?
So new billing, that still has to be up in the air. Right now, the plan is with the developer or whoever is going to be taking and installing those systems. It's not being paid under any grant program that you currently have, so they would be.
But the pipe, they could connect to the pipe and.
It'll be available.
Yeah, the connection to the force main pipe.
So any of the new development, the developers are paying for the installation of the pumps.
If there's new roads going in as part of that development, they would be responsible for putting in the low-pressure sewer and connecting to the sewer that's being installed as part of this project.
I think really our intent with this slide was just to wrap our minds around questions that people are going to ask about these types of systems when we do additional public outreach. Because like Sean said, while it's an old technology, it is somewhat newer in the area. So we know people will have questions about it and be looking for reassurances about things like electrical use and maintenance. So we just want to be sure we can answer those questions accurately.
But the installation's paid for by the developer and the connections, but the maintenance, are they gonna be on their own maintenance schedules too? Are we only maintaining them?
We're only talking about the existing people.
Existing.
Our responsibilities for existing, and anybody new would have to maintain anything anyway, right?
Yeah.
So that's normal.
So now we're running out of time, so just can jump ahead to work done to date. For public engagement, the town has a website for this project specifically, and there's been some publications that have been posted there. There's an infographic that Arceus in the town put together describing this project, both in English and Spanish. We had 2 in-person events conducted earlier this year, one at the Phillips Avenue School, talking with individuals there, and at Franca in March. We have developed a public participation plan that will be going to DEC along with the speedies permit application that's required. And that requires additional outreach and education. So we were going to be working with the town moving forward to have different town halls, meetings, or meetings with different stakeholder groups to discuss this.
And with the first being the first Franca meeting of the year.
In January, we'll be meeting, that's
Crew
great.
will all be there along with Paul and Elizabeth.
Oh, perfect.
And are we bringing the tape? Great. And we'll start with that.
So how are we doing on the cost estimates that we had originally? Because this, I've been looking at these pages for 5 years now. So are we, the grant money we're getting in, we're still pretty close, and how are we looking?
We are on the EFC's agenda for October 23rd to get official approval to go toward closing on that bipartisan infrastructure law money. So we have a few different pots of money. That was 19 million. We did recently get the award from EPA, the Chuck Schumer money. That was preserved. It didn't go away. We have that. We have ARPA, and we have CPF. So all of that, and we built in a cost contingency of a decent amount, 35%. So that's why we're still okay, because we had those projections with a huge contingency.
So the most recent cost estimate, it really hasn't changed since over the past year when the map planning report cost came out. For phase 1, we were estimating just about 43 million. So I think we had planned around 44 million or so in the map planning report. So we're good there. Total project costs, that's including phase 2, the future build out. So finishing the sewer in the streets that are connecting the existing homes and putting the equipment in the treatment facility is around 60 million.
Yeah, phase 2 is going to be another whole round of trying to get, but then Suffolk County has that new sewer money. We've never received any money from DEC, from their
Right,
water
we're gonna
quality
get DEC
funding.
money.
So, but like, I think, any others, Steve, that you can think of? There's other
those are the main
sources that we're gonna look to tap.
We,
Yeah.
from EFC, WQIP from DEC.
Yeah, those are the big pots that, and there's other, state programs that we may want to, once everyone's comfortable with how much affordable housing, we had that conversation last time, there may be other pots of money for infrastructure that we can ask for,
I
depending.
think EFC gives only one grant per project, or would it be phase 1 is one grant and then phase 2? Any idea whether they would
Yeah,
be?
you could apply again for a second phase.
That's why we broke it into 2 phases, because $100 million was too much. So we were like, let's
So
start.
the BIL money, the IAJ, as it's currently called, that money you won't be able to apply for and get ever again. That daylights in 2026, all funds have to be allocated. So that ship has sailed. But the WIA money, the WQIP money, you can apply for both phase 1 and phase 2.
I got a, Janice, down the road, has any consideration on how it's gonna be run? How many employees? Are we gonna be subbing out the trucks, or are we gonna have inside?
You will have to make that decision as to whether or not you want to just, there's a couple of choices, but you could either run it as a municipal plant, or the county could run it, or you can contract out to a private.
What model we choose.
The Probably the least expensive for the town is to contract it out.
Yeah, because then we don't have, all the things that come with it being us.
Employees, yeah.
Employees and.
Yeah.
Retirement.
So it was always sort of thought of, over the years that it would be contracted out, but we did want it to be a municipal plant because of the fact that we were the ones that were able to apply and get the grants and get the, all, and be able to make this work with the CPF and the subsidies and all the things. So, yeah.
Then probably the next important question is schedule.
We love that question.
We are moving towards 60% design, which we'll be submitting in January, 90% design in July, 10%, which would be going to the regulatory agencies, New York State EFC, New York State DEC, Suffolk County, in September. And then there's a period of time they're going to have to do reviews. So we anticipate that this project will be out in the street for contractors to bid in February of 2027.
And it could go faster
could be
if we
going
get the
faster,
approvals
yes.
before then.
And we will be constantly communicating with the EFC, DEC, so they know what this project is. So hopefully their reviews will not take as long as some projects. And then we show a 3-year construction window. Then that, it really depends on the contractor, but that's the window that we're showing. It'll start up in 2030. By 2030.
The 60% design, you need to give us a proposal for that?
So there is some money left in our contract right now, so we're accelerating some of the parts that we can right now. So there's not a slowdown, but yes, we are working on buttoning up that proposal for the 60% design through bidding for right now. And then the construction phase service that we would be providing would be a separate proposal, and then you would have an RFQ out for construction management services and construction inspection.
When do you think you'll be sending the proposal?
I've been saying it's next week. I'm really hoping it's gonna be next week or the week after that you'll have that.
Yeah, thank you.
I just want to say thank you to Steve. I mean, you were the supervisor and I attended some of the meetings where we were having the discussion about whether or not to go with, the gravity sewer with pumps, and, there's a lot of information to process, and it's nice. I mean, not that we don't trust you, but it is nice to have a second set of eyes on everything, asking questions that we don't necessarily always know to ask. So it's been a really, it's a long process, but I think people don't really understand how much goes on behind the scenes, and the work that's done, Janice and Teresa. I mean, just with the grant writing and everything else has been amazing.
Thank you. Yeah, we're like, we don't want to do anything wrong here. We want it to be like the best thing we could do. So,
Sewer projects are
thanks.
very complicated and hard
Yeah.
to get done, so it takes a lot of people to work together.
It's a great team. And all of you have been super supportive, and we're really grateful for that as well. So,
It's not all that common for municipality to do something like this, so we're
That's
very
the
proud
first-
of what you've done, Janice and Teresa and Kathleen and everybody in-house, and you put together a great team. Thank you for your insights. So.
thank you for being part of it, because you're in there. You're hands-on. You've been in
I
the
do
meetings.
love this.
So it's great.
You guys have great questions.
Yeah.
That's one last question for me. The startup being around 2030 sometime, how does that affect any of the projects, like our affordable housing projects or any other developers?
So, in the wrap itself, it has said you can go through full design and site plan review and then get to the point of construction where all you're doing is connecting. So a 5-year window seems like forever, but it's really like a blink of an eye. And if we line it up, right now we're still in that let's make sure we all know what we're getting phase, and making sure the wrap and everything matches the way you want it. When we get to the point where we're satisfied, someone can propose a project consistent with the pattern book and wrap and go to site plan, which is, as you know, kind of a lengthy process. It takes about a year depending, but they can go to Project Development Council, which is like a group of us that sit together, the fire marshal, the building department, planning, all coming together to make sure they're meeting everything. And so they can get to the point of, they could get technically building permits and build and then line up with connecting with the sewer.
Subject to connecting,
Subject
because
to
usually
connection.
that
So
they
we
would
wouldn't
have
give, see,
to.
it's a risk,
Yeah.
but they could, so that you can build and be ready, connect when this is built and done.
But the
You know,
planning
you don't have
board
to
would be
wait 5
willing to
years
do
start.
that, because normally
law
they'd have
allows
to
it.
get,
The code right now today says you can do this. So unless you change it, they could technically get the plans approved, pull permits, build, they just can't get COs, you can't
I
occupy.
mean, we're talking about in 27, construction begins, so it's not really like,
It's not that far
they
away.
start the process in a year? You know what I mean? It's,
But you
That's what I was
could
thinking. You
line
could
up.
probably put a shovel in the ground by the time you're done with your permits and all your planning in 2027, anticipating.
and it's not really a risk when it's already going in the
Yeah,
ground.
once we're under construction,
Yeah.
I mean, it's not as big of a risk because we know what's happening. So we're trying to make it line up. So somebody's like, oh, I gotta wait 5 years before I can even do anything. No, we think that you know, we can line it up and do it together.
It's a pretty conservative schedule too, so.
Yeah.
Try to beat it.
It's good to.
we'll try to beat it.
We'll try to get it.
So first flush,
under budget, right?
potentially 2030.
First flush, love it.
First flush.
Different party.
750,000 gallon peak when everything's done. Is that in anticipation of just a peak usage or further expansion?
That's for diurnal flow patterns, so in the morning time, more people flushing, it may just be instantaneous, that short duration peak.
Yeah. So, no,
The
the,
facility is designed for an average daily flow in full build out of 500,000
Right.
gallons a day. That's like a peak hourly flow projection, basically.
and those are conservative as well. I think we'll end up having some room in the end because all of the way the health department makes us estimate, it's actually overestimated. So you have it built in.
Well, for a good reason.
Yeah, so they make you build in more capacity than you actually need.
Yeah,
believe
actual
it or
flows are typically like 75% of what we designed for using the health department's flow standards, so
Yeah.
we should be in very good shape.
And the peak is if everybody flushed their toilet all
Right,
at
I-
once at
like
max
a Super Bowl
capacity.
Sunday
or
or
I'd be able
something.
to say that.
That's a good example.
Commercial break during Super Bowl.
So the difference, like if you did the same idea in Hampton Bays, the distance to the STP is just a matter of a pumping station.
And we have our friend Stevie.
Yeah. And the pump stations can look like little houses too, you know, they're pretty
Luckily, we
harmless.
won't need pump stations here in Riverside. It will all be this and with the grinder pump, so we do not need that, which is really a cost saver. So that's great.
Yeah.
Great,
All right, well,
Thank
thanks
you.
very much. We look forward to
Thank you for
seeing you
having
next
us.
time.
great.
What was the Petro project? Thank you.
Thank you.
Pretty much the entire South Shore.
Oh, really?
So they just did, yeah, so the original one that they had done was down West Ave.
I don't know, with this one
yeah.
weird year.
I think you would.
Yeah.
I don't know if I have it in me, Mike.
Over the last 2 years, we've put another 238 pumps down there, including we actually, unique one, we actually take the backwash from the town pool. And we pump the entire backwash of the town pool with one of these pumps. Not an normal design, but per county standards, you can't share a pipe unless it's the same pump. So otherwise they would have
Bravo.
an entire like 7-mile dedicated
Thank you.
force main. So it's like we just overbuilt like an EQ tank and we pump it out. About 15 gallons per minute, they give us 6,000 gallons a day.
Sorry about that flag.
Oh, yeah, I didn't even see it coming. Nice try.
Wow.
I had a ball.
Just hit my
I
Cali.
was worried about you.
Projects there.
Too.
You guys gonna carry that thing out of here now?
Yeah, we wheel it out with a hand truck, but it's actually not too bad. I make him do all the work, so I can say it's not too bad.
Oh, it all like locks into place?
Yeah, so what happens is the pump sits inside the tank, and there's a locking mechanism on top of the pump where 3 arms come out and actually lock it into the tank, and then it locks the discharge in. So when we go onto a service call, we have what's called a tank wrench, which is about a 6-foot-tall Allen wrench. And from above, we can actually actuate all that. And the deepest we have to stick our arm in the tank is just wrist deep to grab that EQD at the top. And we can swap a pump in about 5 minutes. An amateur can do it in about 15.
Wow.
Really, the whole pump?
pull the whole pump right now, not the tank, just the pump. So that's what I mean, is, customer calls, or you get an alert, punch an alarm, someone goes out there, yeah, they just pull the pump out, unscrew it, plug a new one in, drop it in, operational.
Nice. Yeah.
Go get the hand truck.
Yep.
Okay. Sorry, this will just take a minute. Any other questions, though?
Do we want to move ahead with
Yeah, they're
updates?
probably out of screenshots. So this is when we normally do our supervisor and town council member liaison updates.
Wait, I have one question.
Yes.
It says finished grade is up there, but it says do not bury this.
This is for shipping purpose.
Oh,
So that's
okay.
where your inlet pipe goes in. So for example, you were looking at that timeline on your project. So in there you had the building of the treatment plant, and then you also had the installation of these. So they can put these in the ground, they can connect them to the road, but obviously you wouldn't be able to connect this to the house until the treatment plant's ready to accept flow. So what we tell them is stick a piece of pipe in here, about 5 feet out, glued cap here. Because what we don't want is if they backfill this and then come back, let's say 2 months later, and dig up just this side, the tank's gonna wanna fall that way. So we tell them, give yourself at least a 5-foot stub, and a lot of the ones, they actually went almost 25 feet back to the house, capped it there, but this is not watertight.
Okay.
So I actually was involved in a project in Connecticut many years ago where they buried these, and then the project got put on hold, and they sat there for about 9 months. And we had to pump mud out of every single tank, because that's not watertight. It's just for shipping purposes, to keep that grommet from falling out during shipping.
We didn't ask what's the cost of each unit,
So
with
that's
and
always-
without the installation.
So I'm assuming that's built into their numbers, but what I can tell you is that we have a contract with Suffolk County DPW that Patchogue, Northport, and a couple other people have piggybacked off of, and we allow pretty much anyone in Suffolk County to do that. That contract is due to expire next year, but they're probably going to renew it or rebid it, so you will be subject to that price. But hypothetically speaking, for budgetary purposes, figure about $7,500.
Oh, wow.
That includes the pump, the tank, a 50-foot cable, the panel, and pretty much everything they would get from us. So this is not expensive.
Plus installation.
That's the variable. So what I could tell you is that anywhere but in Suffolk County. No, you're fine. If you left Suffolk County and had this tank installed even in upstate New York, 25 to 30,000 to put one in Suffolk County, maybe double that number. They've been pretty hefty prices.
For the installation, you're saying could be like
Yes,
$60,000?
I make the same face when they tell me.
Wow.
They seem to have been pretty steep on installation, so I think that's a number we're seeing come down at that people have more experience with them and they've done more. I mean, it's a very plug-and-play unit. There's no drilling that has to be done. This tank looks, aside from the hole in it, looks just like this. The hole's already there for the inlet, the connection's already there for the discharge, the cable just gets pulled out and run back. It's not a very difficult installation, but that also included abandoning the old systems, running all the pipes from the house into here, from here out, so.
Oh, I meant just to replace it.
Oh, I'm sorry, I thought you meant to put this in the ground.
No.
So a replacement pump, we charge, if we go out to like a customer that owns their own, we charge about $4,500. That includes the pump, time, labor, everything. With a 2-year warranty, that's standard, you will get a 5.
How can it be $4,500 to
Well, it takes you
replace
5
it when you
minutes.
said it's $7,500 for the unit itself?
The unit's just the plastic.
Well, yeah, so that includes the tank and the panel and the cable.
Oh,
So there's other components. So the
Oh, I
pump,
see.
like I said, we call that the core. That's that pump that's hanging in there. And again, the list price on that might be $3,700. We charge, a little bit for labor and all that type of stuff. But when you buy the unit, you're getting the whole package, so it's everything included. So the panel itself, like this particular panel, it's about a $1,000 panel because it's got the communication system in there, generator receptacle. Plus, I didn't touch on it much, but these are smart panels. So this is actually measuring the voltage of your line voltage coming in from the house and the wattage of the pump every time it runs. And there's a certain parameter that those need to be in to make sure that everything's good. If the voltage goes too high or too low, the panel will shut the pump off to protect it. If the wattage goes too high, which normally means that the pump is pumping against a blockage, it will shut the pump off to protect it, and it will then alert someone saying, there's something wrong here. So that panel protects the asset of the pump.
See that data.
Yeah, you have all time, it's almost like a wireless SCADA system. You can see all the time run cycles, pump cycles.
We know all about SCADA system.
We'll go back and look at our budget for that though, because knowing that, we should look at that, make sure.
Thank you. Be careful.
Let me go around. Open the door. You got it? Okay.
They should put in the water meters.
Take it right. Made it just right.
When I said bring it with you, I
Perfect.
thought they were talking about like this small thing.
I know. All right.
Good visual, that's good.
Cindy, you want to get us started with our
Updates?
liaison updates?
There's not much. I've just been going around talking to people. I had a CAC meeting in East Quogue last night. They are very excited to move the Park District forward. I spoke to them about the additional money in the budget for the East Quogue Village Green. Very happy to see those upgrades coming down the pike. I told them that as soon as we have some renderings or some more information, I will bring it back to a meeting. Something else I did want to just bring up that we are kind of, at least I have been mentioning to my CACs, is the potential of moving forward with CACs is moving to quarterly meetings. I think we would get more people involved because right now to commit to a monthly meeting every month is difficult. And, you know, I added that to the caveat of, you know, of course, if there was more going on or you wanted to meet independently without a town board member, you're free to do that. You know, if there's something going on, absolutely, we can meet more often. But I think potentially moving it to a quarterly meeting schedule and then asking that members actually attend those 4 meetings makes it better than right now. We have some bit larger CACs, but because the meetings are monthly, people don't come to every meeting, so you don't always have a full board represented. You might have, you know, 4 people at one meeting and 8 at the next. So I think it would give people a better option to be involved and to know that those 4 meetings are going to be core updates. It's also, you know, meeting monthly. It's hard, as you know, in government to get anything accomplished in a 1-month turnaround. So when they bring us concerns, to give 2-3 months for us to work on things and really dig our teeth into would actually, I think, be beneficial. So, I'm just asking for feedback on that at this point.
I would also add too, it gives our staff, our legislative staff, more flexibility. You know, when there's questions that are asked, they have more time to kind of flesh through some of those issues.
Yeah, I think that's a good idea to just, you know,
There's
float
also
it out there a little
some
bit.
of them are also having trouble coming up with agendas
Right.
monthly because we're kind of
Yeah.
talking about the same thing.
Yeah.
So.
And they all take a holiday break and a summer break anyway, so it kind of fits in the schedule.
Yeah.
Yeah, let's all mention
Not saying we're
that.
doing it, we're just putting it out there, and
Yeah.
so far I've gotten positive response to that.
Good, good.
So I'll just mention really briefly that on November 1st, we're having our town's Disability Resource Fair at the Hampton Bays Senior Center at 12 o'clock. There will be a number of services and resources available for families that have family members with special needs. I just want to give a shout out to Jamie Bowden, who's been working very diligently, and our Disability Task Force that have been organizing for this. It's going to be our 2nd annual Disability Resource Fair. The first one was very successful. We're hoping for, if not the same amount of folks, but more. It's going to be again at the Hampton Bays Senior Center. We hope to see all of you there. So please spread the word. That's it.
Okay, yeah, that's good. I know it was fun last year. The performers. I forget the name of the, you know, the
Oh,
little
the East
group.
End Special Players.
Yeah,
Yeah.
that was really cute.
Yeah.
All right, and I hope everyone had a nice long weekend, and I was at the West Hampton Beach Main Street Fall Festival, and it was really very well attended and lots of fun activities. So I hope everyone enjoyed the weekend. Bill?
Well, I got some word from the consultant for Long Neck. He got some comments back from the DEC, and he answered them and sent them back, and hopes to have the permit in a few months so they can start on that project. The other consultant sent the DEC a letter to see where the Bel Air or the Penny Pond permits are, because it's like dragging along. And
Well, I'm glad they're following up on that.
so, yeah, I call them like once a
Yeah.
week. And it's hope to have some type of answer back from the DEC where it's sitting soon, I hope. If not, I have to go up to see the DEC.
Yeah, keep bugging them. Thank you, Bill. Rick?
So two quick ones. Youth Bureau on October 24th at 6 PM is having their open mic night at the Hampton Coffee in Hampton Bays. Be a good night to come out and see the kids.
When is that?
The 24th at 6 PM. And Franca will have their trunk or treat the next day, October 25th at noon at Ludlam Park.
Thank you. Weren't you on the judging panel for the open mic night?
No, there's no judging panel for this
Oh.
one. It's just more of a, you go and you could, play a song, you could do some poetry.
Oh,
Yeah.
Are you
That's,
going?
That was
like a talent show.
Battle of the Bands judge. That's
Yeah.
what you are.
That's what you were.
and Hampton's Got Talent.
So many things. All right, well, if nobody else has any other things to discuss, then I move to go into executive session to discuss acquisitions.
Second.
All in favor?
Aye.
All right, thanks, everyone.